Today I want to demonstrate to you how we can transform an AC voltage source and get a DC output. And we are going to use the LTspice software we talked about. It is here. If you look at my desktop, you can see the icon for the LTspice software is here. This is the one you're going to be using to do that work. So this is what you're going to be using to convert AC signals into DC signals. Alright, so there we are. So let me click the LTspice software. This is what I get. And let's go to File, New Schematic. Now this is the canvas from where we're going to draw our circuit. So first of all, let's understand how we can use this software. First, you can see this menu. Let's look at this menu bar. This is a menu bar from where you can see various icons that you can use for this work. I can see, let's start from the right here. This is a diode, you'll be needing it. Then this one is an inductive capacitor coil. This is a capacitor, so you can see. This is a resistor. This is a voltage source, so you can convert it to AC or DC if you want. This is the ground. Now these are the wires for connecting. So if you make a mistake, we can undo here or redo. So those are the buttons that you'll be using. So we are going to do our work. We are going to rectify from AC to DC, and I want to use the full bridge rectification method that we learned about. So I'm ready for diodes. So I'll click on that, and then I pull down. And you can see my diode is facing down. I want it to face to the light. So to make it face to the light, I'll come to my laptop. I'll click the control button, and as I press it, I click the arrow button as well. You can see if you're holding the control button, again click the arrow button again. I do the same. The control is still held. I click the arrow button again, and now it's facing the right direction. Then I touch on it and click. And now I can pull this a bit to give me the circuit diode. I can pull this again down there. I want to make sure they're in line. Click again. You don't have to be in line, but I want to make sure they're in line for the best, so that it can become easier. It looks nice when the diodes are equally spaced. I click there. Once I finish, I click the escape button to get rid of that function or functionality. I want to click this negative to make this smaller. So if I click that, you can see now it becomes smaller. Here I want to put a transformer, but there is no transformer up here. So what we do, we'll take an inductor and place the primary coil of the transformer here. We pull that out a bit like that. Again, Control R. Yes, it's facing the other direction. This now is the secondary coil of the transformer, and I click there, and then I click escape. Oh, it looks like it's not in line. Let me undo. So let me pick this again, the coil, and it's there. Control R, and they are not in line, so I want to make sure that I click somewhere there and come out of it. Then it's not complete. I want to put a voltage source here. I need a voltage source here, so I'll pick this voltage source. I'll bring it here. And I'll click. Then I'll escape. Then on this light side here, I need to put my load resistor. So I click on the resistor here, and then I bring it here. I click once, and then I escape. Good, there we are. Now I want to use the wire to connect this up. want to start by connecting the diodes. So you can see I can click that point, and then I can just moving the line forward. Then when reach a place where I want to turn, I click, then I go down there. I want to click there, I go back. Yes, I can see neither. I click there, then I go up, and you can see I've finished connecting the diodes. This side, the primary side of my transformer, needs to be connected to the source, to the voltage source. So I click, and then I come here, click down there, I click, come here, click, come here, and this one will not be done, and I click, dash, and I click. So I've done that bit. This secondary coil of the transformer needs to be connected to this one here. Come here, click, move, click, connect it there. There I have it. You don't need to do it beyond. There it is. Then this other side, click here, click, go down there. I want to make them to make it look nice. It's not yet. When it's there, I have to click, and then I see the election. I click, then I go up here, I click. Now what remains for me to connect the resistor? I come there, I put a bit, click, come here, and I click. There's the other side, I'll click, then I'll go a bit down, I'll just come down, I click, and so yeah, click it, then we go this way, click it, then we go this way, click it, click it. That's how to connect the circuit. But as you can see, I'm only having coils here. I do not have a transformer yet. So I want to also give this inductor some values. So place the cursor there, the inductor, right click, and then I want to give this one 1 millihenry, just like the 1M. Then I want to show that value, then okay, you can see it's here. Now I'm having my inductor L1 is 1 millihenry. I come here to the second one, place your cursor there, right click, give it 2M, 2 millihenries, then also show it. Okay, it's just shown, it's there. Then I want this voltage source, I want to change it to sinusoidal. So we come here, right click, then at first we use the second one, the sinusoidal function. Come here, giving it an amplitude of 10 volts and a frequency of 50 hertz. Good. And I'm also going to give it an internal resistance of 0.05 ohms. So you need to do it like this. Always make sure you give it some resistance, internal resistance. But it's more internal resistance. Don't leave it blank. Then I click OK. What remains is these diodes. But before I go to the diodes, I'm not having a transformer yet. What I'm having are just inductors. I need to couple these together. So I need to come to this. You can see it's being called SPICE directive. Okay, SPICE directive. So I click it. Then this box will appear, and here we're going to put K, capital K, space L1, space L2, space 1. So it is not properly done. Let me repeat that. So capital K, space L1 for inductor 1, space L2 for inductor 2, space 1. So you have to put 1 at the end for mutual inductance. Then OK, and then put it there. click there. It's there now. And now after I finish with now I'm having a transformer here. This is the primary coil of the transformer. This is second coil of the transformer, and the two coils have been coupled using mutual coupling. The one is mutual coupling. Now I go to the diodes. Click there. I pick a new diode. You can use any of these diodes. I want to use the second one. Go to this, right click, not that way. Go into the diode itself. This there, right click, pick diode, click the second one. Place your cursor there on the diode symbol, right click, pick a new diode, right pick the second one. You can pick any that you want. And then I do that. I finish for all the 4 diodes. Good, the diodes are done. Now I do the same for resistor. I put there, and I want to give it 5K, 5 kilo ohms. Just hit 5K, and it's defined. And now we are fine. I think now you can try to see if the circuit is working properly or not. If the circuit it has no errors, it will be able to run. If it has errors, the system, the program will be able to tell us that. So to test that, let's click this learn button. Yes, it tells us there's something that we did not put. The steps, we never told it the steps when it is learning. So let's give it a 0.05 seconds. So we click OK. So yes, it is. It told us it is trans 0.05 seconds. That has been done. Let's check again. Click there. Oh, there's an error that has been found. The circuit does not have a configuration path to ground. Yes, we need to put some ground resistance. We need to put some grounding here. So we pick this above. On the primary circuit of the transformer, a ground, and on the secondary coil of the transformer, we put another ground. Good. I think that does it. Let's see what happens. We check. Now it works. It works. So if you want to see the input voltage, you can come somewhere like here and click there, and that is the sinusoidal waveform. I think you can see it. It's green in color. That's the sinusoidal waveform that we have. We gave it a maximum voltage of 10, but it's not yet reaching 10 because it has some internal resistance. But you can see that is what we get to at that point. At this other point, if you want to see what we're having, it is the same supply. Let's now see at the secondary end. What are we having here? You see, that is what we have in the whole. So you can see when you're at the top, this one here, you can see that is 0. So you're having half wave rectification at that end. So that is the half wave rectification. Half wave rectification. What about this lower end here? You can see we're having the other half wave rectification. The other half wave rectification. And so one is red, the other one is blue. So those are the 2 half wave rectifications. What about here at the resistor, at the load? Let's see what we're having at the load, because this is what you're looking for. Yes. I think the others cannot be clearly visible, so somehow we might have to. Can we see it? I wanted you to see the full wave rectification. The colors are not clear, so let's do it. That is the sinusoidal waveform that we have. That is the input. If you want to see the output at this end, you can click here, or even here, the same for this. Then you can see what you have there. One half of the wave have been rectified. The other side will give us the other half of the wave that has been rectified. So click there. The other half of the wave has been rectified. So it's a half wave rectifications together. Now I should be able to get a full wave rectification if I click here. Good, but it's not possible to see it clearly. So I think I need to to show that again. So let me move this process again. I click here, and then I need to show you what's happening here. Let's bring this way. So the waveform, the source. Then I need to show you now what's happening here. Yeah, that's a full wave rectification. Good. And you can see the way the waveforms look like. That's a full wave rectification. Now we need to add a capacitor somewhere here, a filter, so that we try to reduce this ripples. Reduce this ripple because we want to get AC that is not having big ripples. In fact, we want to reduce those ripples to almost zero, but we get a constant AC output. So we bring our capacitor here, let's bring it here, click it, get out of it. Let's get this one. I want now to come here, I click there, and I connect that capacitor in parallel to my resistor. But I need to give this capacitor some value, so I put that cursor there, right click, and I give it 1 microfarad. 1 microfarad. I just typed 1 U, because there's no micro in the keyboard. Use the U. Then I click OK, and now you can see it has given me this 1 microfarad capacitor. I think now we are ready to simulate this. So I want to learn it. You can see the waveform that we formed. See the waveform that we have. That is what now we have. That is it has been rectified. Let's change the value of the capacitor. Let's give it 5. Let's give it 5 microfarad and see what happens. Okay. Let's learn. Alright, you can see the way it is changing the ripples. Let's change the resistor to 1K. To 1K. Give it 1K. Let's see what happens. Let's learn. You see what has happened? Things have become worse. So let's change the resistor to 5K. And let's make the capacitor 10 U. Then let's learn it. You can see it's become even more straight. So this is the kind of behavior we expected, and you can see the maximum voltage is increasing now 14 volts. Remember we gave it 10 volts down here. It's now maximum of 14 volts because of the capacitor is drawing some charge, and that's being released to the load when needed. So you can see we're also increasing the voltage. We give it 10 volts here, but you can see we're having a maximum here of almost 14 volts. And so that's how you simulate. And of course, as you can see, this is not a perfect DC, but this shows you how rectification is done. So this is a simple filter circuit. So if you want to get more best, a very nice DC, then you need to use a proper filter circuit. But this for demonstration purposes is showing how the works are happening. Okay, thank you. I hope you'll also use LTspice and try to draw your own simulation circuits like this and see if you get similar things like the one that I'm getting here. Remember, when you are drawing this, you must couple your two inductors, and you need to use mutual coupling. Use one. Very important here. You can use the same values that I've used here. Transition should be 0.05 seconds. So remember that. Remember to give your voltage source. Some internal resistance. I'm giving mine here 0.05 ohms. So give it some. And you can use different diodes. Are the one that I used to give some positive results, but you can start with mine and then see if you first of all get get waveforms like this. Alright, I think I'm through with you for the, we come through with this now. And if there are questions, I'll be waiting to hear from you. If there could be something that I can add, if there are issues that I can address, if you find more difficulties, if you are unable to generate this type of waveforms, I think you let me know. Okay, thank you, and let's stop it at that.